Hey guys, welcome back. In this video I just want to talk a little bit about how I think science, like in general chemistry, physics, biology, and all these different sciences are set up and how they are intertwined with each other. Because I was looking over chapter 5 and I realized that there's a lot of physics concepts in this section, and while I was going through this section, I remember that I had to look up a lot of physics videos and a lot of physics concepts. I would look up thermodynamics, right? And I would just find physics everywhere, nothing related to chemistry. And what I learned and what I believe about how physics and science in general is set up is that science, chemistry, is said to be the central science. But I just think that it's one of two. I think really that chemistry and physics lay the foundation for all of science. I don't want to exclude biology because biology is a big science and it is on its own. But chemistry and physics underline all of nature, okay? And then chemistry and biology come together when you're talking about molecular biology, which could be considered biochemistry or molecular biology or organic chemistry. To me, it all intertwines, and if you learn one, then you're learning some of the other. Okay, so in thermodynamics, which is what I'm about to start making videos about, it is very intertwined with physics. So if you don't understand some concepts of it or some of the reasons behind the derivation of the formulas, it's understandable because you're not going to be learning very in-depth physics. You're just learning the basic concepts of how reactions happen in the transfer of energy through reactions, okay, which is really called enthalpy. It's just the term for heat transfer, okay? And really you will find this throughout all of chemistry, so I might as well talk about it now that I'm making this video. I was looking over chapter 6 as well, and chapter 6 is physics, quantum physics. It is quantum mechanics. It is wave functions and probability functions. And I remember when I was reading this, I was like, what the heck is this? You know, it's all this physics concepts. It's telling you how they can't determine where the electron is located. Where is the electron? They can't tell you. It is according to quantum physics. I really don't know much about quantum physics. I am just barely now learning kinematics in physics. I'm taking physics this year. But what I do understand and what I have researched and watched videos about is that when you get to the quantum level, the super small level, that subatomic level, things get weird, you know. Newtonian mechanics, which is basic physics, the physics of I throw this pencil and you calculate the friction and the velocity and the angle at which I threw it at. If you knew mechanics and kinematics, you could tell me very specifically where this pencil is going to land. But what happens is that when you get to the quantum level, it breaks. It breaks down. The equations don't work. It doesn't predict it anymore. Okay? So in that sense, science failed. Okay? But when you're talking about macroscopic big, then mechanics works. Okay? But when you get small, you start talking about quantum mechanics, and in that level, you can't measure an electron's position, okay? So what scientists came up with, actually Niels Bohr, he came up with quantum mechanics and said that you can't measure it. The best that you can do is give a probability function, a function like this, that tells you where the electron is most probable to be, okay? You see the part where it peaks? That's where it's most likely to be, okay? And I will go much more into depth about this, not the physics about it, but just the idea of what you need for chemistry. But just know that as you study chemistry, chemistry is not alone in itself, only chemistry in this book. You're going to have a lot of physics. And as you get towards the back, organic chemistry, you're going to have a lot of biology concepts. And you're going to have to deal with some gaps of knowledge, okay? Some gaps of knowledge that you don't need to know, but it is really nice to know, like deriving and understanding these concepts. But you're going to have to deal with being at a loss of some knowledge because it doesn't directly apply to chemistry. It's a physics concept that helps chemistry. And yes, that is about it. It's just something that I wanted to give you guys a heads up because I had to deal with this, and I was kind of at a loss for a while there. So yeah, hope this video really helps.